Before I even get into the new type of proof and how it's going to go, I need you guys to have an ability for me. And that ability is to recognize what's called a contradiction. Two things that cannot happen at the same time. So what I've listed right here are three geometry statements. DEF is scalene. Hopefully you remember what that meant. And triangle DEF is a right triangle, and angle D congruent to angle F. Two of those cannot happen at the same time. It's virtually impossible. It is impossible, excuse me, to happen at the same time. So do it by yourself, talk it over with your group. I'll give you a couple minutes. Which two statements up here can never, ever in geometry happen at the same time? All right, so look those over yourself or talk it over with your group. And we'll come back and talk which two cannot happen at the same time. And make sure you understand why they can't happen at the same time. All right. Got to know what scalene is. Remember what scalene is. That's the key here too.
Is that scaling difference in values of triangle?
Any group or any person think they have the two that cannot happen at the same time? Yeah. 1 and 3. What's scalene mean again? No sides equal, right? No sides equal. So if I throw a triangle up here, DEF, no sides equal, but it says number 3 says D is congruent to F. What type of triangle did I just mark right there? That is what? Oh boy, come on, don't do this. That's isosceles. What's across from the congruent angles? That can't be scalene. If I have two congruent sides, scalene means no congruent side. So yes, 1 and 3 cannot happen at the same time. All right, 1 and 3. Good job. I'm asking you this because that's what's going to happen in our proofs today and tomorrow is we're going to have two statements that cannot happen at the same time. It's impossible, called a contradiction. Just to let you guys know, we are doing what's called an indirect proof. This is what these are called here today, an indirect proof. The steps are here. If you forget, my best way to teach this to you is to throw you right into the fire. Okay, we're going to go right into the fire here with number 1. I'm not going to hold hands and read the steps on how to do an indirect proof. Very first thing I got to talk to you. Why? Why do I have to do this differently? What was wrong with our old method? Why do I have to do this new way called indirect? Everyone look at the proof statement. Right now in number 1, look at the proof statement. That's something we've never seen before, has it? I have never asked you to prove two angles or two sides not equal to each other. So right there, if I'm asking you to prove something is not happening, that tells me this needs to be an indirect proof. That's the key. Look at the proof statement. All right, that's the key. Because on the test Thursday, on the midterm we're going to take in another month or so, on the Regents exam at the end of the year, I guarantee you the directions will not say, hi, do this indirectly. It won't say that. So how are we going to know we have to do it indirectly without the directions telling us? It's going to be the proof statement. All right, if I'm ever asking you to prove something's not happening, we got to do an indirect proof. Okay, we have to do an indirect proof. Notice something in the givens too. We've never had that in the givens, right? BD not equal to BE. We do have AB equal to BC, so let's act like we've done proofs before and mark it on our diagram. All right, there's a lot of things I'm not changing here. However you want to mark AB congruent to BC. And everyone notices step 1. That's all the same, right? Givens. We always write our givens in the first one. Here's where it's going to change now when we do a proof indirectly. And this is going to be uncomfortable because it's brand new. Just let me get through at least 3 of them today and you'll feel more comfortable. When we do an indirect proof, after we write the givens, our next statement is going to be an assumption we're going to make. All right, we're going to make an assumption right now. And this assumption is the same for every indirect proof. We're going to assume the opposite of our proof statement is true. Let me say that again. We're going to assume the opposite of the proof statement is true. So if A is not congruent to C is our proof statement, what are we going to assume is true? Angle A. What's the opposite of that? Is congruent to angle C. We're going to assume that's true. And I want you to watch what happens because this is going to lead us down a dark place, a real dark place in geometry, assuming that is true. Mark it now. We wrote it down. Let's mark it. We're assuming these two angles are true or congruent. It's going to lead us to a bad place, kids. Watch where this leads us to. Real bad place. Wait. This is almost starting to look a little familiar here. I got these pair of sides. I have these angles. It almost looks like we're trying to do what to a pair of triangles here? Think about where we've come from so far this year. I got a pair of angles. I got a pair of sides. It's almost looking like we're going to do what here? Prove a pair of triangles congruent, right? And that's exactly what we're going to do here. We're going to prove these two overlapping triangles. And just stick with me. All right, just stick with me. We're going to prove these two pairs of overlapping triangles congruent. We already have a pair of angles, and we already have a pair of sides, which means to us I need one more pair, right? One more pair to prove them congruent. Where are they? You and your group discuss it. Where's that other pair of congruent sides or angles in those two triangles? Because once you get that other pair, they'll be congruent. So we already have the sides. We're assuming A and C are congruent. So there's the pair of angles. Where's the other pair of sides or angles? Talk it in your group, please, or if you can find it by yourself. Find me a pair of angles in those sides in those two overlapping triangles that you think will be congruent. You got to find it yourself because there's not much else in the givens to use. What else do you see there that we could use? And it's nothing new. I've shown this to you before. This is nothing new. All right, any groups? Anybody individually see something I could possibly use? Alex, sure.
Angle B.
Hey, everyone look at angle B. That's an angle in both those triangles, right? Angle B. Nice. So yeah, angle B, congruent to itself. What did we call that property? Reflexive, yeah. Not much has been changed, right? We threw a little assumption in there, but nothing much has changed yet. All right, those two triangles are now congruent. I just need somebody to give me a method. So triangle, let's see, ABE is one of them. Congruent to, let's see, if I go ABE, how do I have to name the other triangle? CBD. Well, I have two angles and a side, right? So it's either going to be angle, side, angle, or angle, angle, side. Got to see if that side's in the middle. Anybody remember my little tip? If you don't know if the side's in the middle or not, when they overlap, what was my little tip? Take one of the triangles and draw it out if you have to. If you can see if that side's in the middle, you don't need to. So I'm going to draw out BCD real quick. Mark all the markings I have. I have angle C with an arc mark. I have BC with a hash. And then we just marked angle B. Pretty easy now, isn't it? What's the method? Angle, side angle. All right. Where is he going with this? Trust me. It's going to get nuts here in a second. All right. So back last unit, unit 4. I showed you guys, hey, once you show me two triangles are congruent, what do you know about all the parts that match up now? All congruent. That was CPCTC. Everyone remembers that, right? So once these two triangles are congruent, all the sides and angles that match up are congruent. Let me say that again. All the sides and angles match up, including, ready? Finish this statement for me. If the triangles are congruent, so are these sides. BD And finish it. What matches up to BD in the other triangle? BD and BE. BE. And that was called CPCTC, right? The corresponding parts match up. You should be lucky right now. None of your papers are catching on fire right now. Because they should be. Anybody want to tell me something here about your proof? Something is not right. Not right about our proof right now. Like I want to look at it and be like, are you kidding me? That this is in your proof right now. This is ridiculous that this has been written down in your proof. Yeah, what's so nuts about our proof right now? Well, weren't you given that they weren't congruent? And now in the very same proof, now you're telling me there are? You serious with that? How can that happen? It can't. Can we all agree on that? That can't happen. There's no way they can't be equal and equal in the same darn proof. This is false. Because we were given that they weren't equal. So this is false. Everyone with me so far? This is false. Hey, what led us to here? What led us to here? By us doing what at the very beginning of the proof? Assuming that that was true. Right? That's what led us to here. So let me do this very slowly. We all agree that's false. Because they told us otherwise in the beginning. That's false, which means what about our assumption now? That also has to be false. So if A congruent to C is false, what must be true? If angle A congruent to angle C, we've already said that is false. What must be true now? That angle A is not equal to angle C, right? If that's false, the opposite's got to be true. And that's what we wanted. That's what we wanted all along. Here's our reason, and here's how we end every indirect proof. What led us to here again? Assumption led to A. And this is why I did that exercise at the beginning. What's this right here? What are these two? I know they're opposites, but what did we call them at the very beginning? Those two are called contradictions. So our assumption led to a contradiction. This doesn't make you great. We're not ready for number 2 yet. Let me review what we just did. You write your givens in like you usually do. Fine, write your givens in. Then we write our assumption. Where do we get the assumption from again? Where do we get the assumption from? Halo? The proof statement, not the givens, the proof statement. We get our assumption by looking at the proof statement and writing the opposite. Now, I knew where this was going to end, so I knew where to lead you. But when you do this on your own, how do you know where to go? You are always going to contradict one of the givens. Always. Which given are you always going to contradict? The not one. Okay, you will always contradict the not one, I guarantee it. All right? So the assumption will come from the proof statement, and your goal in the proof is to contradict one of the givens, and it's probably the given that has the not with it. Let's do another one together before I let you try one on your own. Don't try to get ahead here. First question for everyone. How do I know I have to do this proof indirectly? Why can't I do it like I did in units 1, 2, and 3? What's up there that says you need to do this indirectly? In the proof statement, Taylor, go ahead. In the proof statement, what do you see?
It says not. It does not bisect.
Correct. Does not bisect. Yes. So that tells me, all right, this proof has to be done indirectly. You've written your givens in statement 1. So now statement 2 is going to be our assumption. What are we going to assume in this proof is true? Halo, remind your classmates again, where do you get the assumption from? All right, so everyone look at the proof statement, and we're going to assume the opposite is true. So what are we going to write in our assumption now? That BD bisects AC. The opposite of what's there already. Before we go any further, which given are we going to contradict? We have two up there. We have ABC is not isosceles, and we have BD is an altitude. What's our goal here? Which one of those two are we going to try to contradict? Halo, keep it going. Contradict the not one. ABC is not isosceles. How do you contradict that? Show it. Show it is isosceles. So that's our goal right now as a class. Show me why ABC is isosceles. If you write those words somewhere in your proof, you've contradicted that given. So that's our goal right now. Show me it's isosceles. All right, somehow we need to get ABC's isosceles. All right, please use your given and your assumption to mark your diagram. All right, they're there. Ooh, oh, what was that again? Altitude? Got to know our vocab now. Anybody remember that one from this unit? BD's an altitude. What can you put on your diagram to show it's an altitude? Right angles, good, Jonathan. Right angles, no hash marks. Right angles, yep. And we'll write that in the proof here coming up. Altitudes form right angles. And use your assumption now, too. Use your assumption. BD bisects AC. What are you putting on your diagram now? Hash marks, where? Yes, AC is the one being cut into two congruent parts. All right. Now, remember, we got to put all that into our proof eventually here. Just because it's on our diagram doesn't give us credit. Can we just make a plan before we start writing down random stuff here? How are we going to show ABC's isosceles? What's it mean to be isosceles again? So I need two sides equal, right? For it to be isosceles, two sides. Ooh, how am I going to do that? Like I need AB and BC equal to make it to be isosceles. Ooh, they would be equal if I knew what about the triangles. If the triangles are congruent, CPCTC would say AB and BC were. All right, so get me the triangles congruent right now. All right, let's get the triangles congruent. Can we put our markings into our proof now so we don't forget about it? AD congruent to DC. What's that reason going to be? Definition of bisects or bisector. Good. What other markings do I still need to put in there? Got to put the right angles in there, right? And we know this is a two-step process. Angle BDA and angle BDC are right angles. Okay, I got to stop here and talk. All year long so far, it's been perpendicular lines form right angles. That's what I've had you written. I don't have nothing up here said perpendicular though, so I can't have that as a reason. Why do we put the right angles again? Altitudes, right? So now we just write instead definition of altitude. I know usually we wrote perpendicular lines form right angles. Well, I don't have those. I have an altitude instead. Now tell me they're congruent like we usually do in the next step. Angle BDA congruent to angle BDC. Right angles are congruent. A pair of sides and a pair of angles, right? Sides. Not there yet, though, right? I'm not there. I don't have enough information to say those triangles are congruent yet. Why not, Mia? One more? Yep, don't forget reflexive. We did this in Unit 4. Well, that's what's great about this course. Once you finish a unit, it never goes away. Reflexive. Good. This is a long proof. Buckle up. There's the sides. I think we have enough to say the triangles are congruent now. All right, everyone good? We should have enough, I believe. I see the method we have as well. So we can say triangle ABD congruent to triangle CBD. Little side angles. Well, I just gave that away. Should have asked somebody. Why do we need the triangles congruent again? It's not isosceles. Hopefully we're not writing that in step 8. This isn't isosceles yet. But if those triangles are congruent, which two sides are now equal? AB and BC. And that's CPCTC. All right, now it's isosceles, right? But you got to tell me it's isosceles so I can have a contradiction. So in step 9, hey, now ABC is isosceles. Cross your fingers, your papers don't catch on fire. And we always wrote definition of isosceles. That's fine with me. And, oh boy, we got a big no-no, don't we, on our papers right now? We got this, and we have that. Once you contradict a given, you are finished. Well, I shouldn't say you're finished. You got to write the proof statement because our assumption is false. So that means the opposite, BD, does not bisect AC. Contradict a given. Once you contradict the given, you know your assumption is false, so you can write the opposite. Assumption led to a contradiction. I'm going to come around, sit with groups, make sure these are going okay. All right, you're going to try this first homework one on your own. Write your givens, write your assumption, and then before you start step 3, circle, mark, make a note in your mind which given that you need to contradict. All right, which given are you going to contradict, and then try to do it. All right.